So we learned that for a pure water at 25 degrees Celsius, the dissociation constant of the water is 10 to the power negative 14, which means that at 25 degrees Celsius, the hydrogen ion concentration is 10 to the power minus 7, and same will be the concentration of the hydroxyl ion for a pure water. And we also learned the pH, which is equal to minus a log of the H plus ion concentration, which means that for a pure water the pH will be 7, right? The pH, if you calculate the pH for the pure water, it will be 7. The pH for the pure water is 7. And the most common solutions that we can practically prepare are having the concentration H3O positive ion concentration, or you can say the hydroxyl ion concentrations ranging from 10 to the power 0, this is a very high concentrated solution, up to the 10 to the power negative 14, right? This is the the concentration range, right, that we can practically prepare the solutions. We can prepare the solutions other than this, but they are very rare, right? Most of the solutions that we use are having this range of the solutions, this range of the H3O positive ion concentrations, correct? So that means these two will be the two extremes, okay? These two will be the two extremes of a scale, right, which is called as a pH scale. So if you have a solution that has actually a very low concentration of the H3O positive ion, like 10 to the power minus 14, so at that time for the solution having a 10 to the power minus 14 H3O positive ion concentration, we can say the pH for that will be, the pH should be, the pH will be negative log of the 10 to the power minus 14, so the pH will come out to be the 14, right? So that is the one end of the scale, and another end of the scale will be the pH, having a solution having a pH of a negative log of the 10 to the power 0, which is actually the 0 here, correct? So that means we will get by looking at these two extremes, right, these two extremes of the different solutions, we can have a scale which is called as a pH scale, which ranges from 0 up to the 14, right? It's starting from 0 up to the 14. So we have a pH scale starting from 0 up to the 14, correct? And if you look at the water, as we have just calculated that a solution, the pure water has a pH of about 7, so that means this should be the pH of the 7, pH of the water, pH 7, which is the water, correct? So for the pure water, the pH is 7 here, and as the concentration of the H3O positive ion will increase, this pure water has a concentration of the H positive ion concentration 10 to the power negative 7, correct? This is the H3O positive ion concentration for the pure water. Now if the concentration of the H3O positive ion will increase, that means let's suppose it is now 10 to the power negative 6, right, 10 to the power negative 5, right? So therefore the corresponding solutions will have a pH of about 6, okay? So it will be having a pH of 6, this will be having a pH of 5. So that means if you increase the H plus ion concentration, when the concentration of the H plus ions increases, the pH will decrease, which means that a solution that has a concentration more than 10 to the power minus 7 will be treated as an acidic, right? So this is an acidic solution. Similarly, we can have 4, 3, 2, 1 and 0, correct? So this is one end of the pH scale. The other end of the pH scale will be the solutions where you have a H3O positive ion concentration very less. Like we can take a solution of the 10 to the power minus 8, a solution of the 10 to the power minus 9, so concentration of the H3O positive ion solutions, that keeps on decreasing. So a solution with the 10 to the power minus 8, so a solution of the 10 to the power minus 8 H3O positive ion concentration will have a pH of the 8 here, right? And this one will have a 9. So it's similarly you can have a 10, 11, 12, 13 and 14, correct? So that means now this forms another end of the pH scale. So this is an acidic, and this one will be treated as a basic solution, because here the H positive ion concentrations are very, very less. All right, so water, the pure water, has a pH of 7, and this is the pH scale that we normally use to identify whether a solution is acidic or basic. Hope you got it. Thanks for watching the video. Bye for now.